All right, so to begin this review, it says each angle is given in standard position. Determine the quadrant in which the terminal side of the angle lies. So you don't have to sketch the angle, but it might help to do so. At the top of my paper, I'm going to remind myself where the positive radians lie, where the cutoffs are. And because I see that I have one angle that's not in terms of pi, I'm going to do the decimal equivalents. These are good to have memorized. 3.14, you can figure out half of that. Half of 314 is 157. 4.71, you could just add those two together. 2 pi is double 3.14. So placing this, 6/7 is less than 1 pi, but more than 1/2 pi. So we've got to be in quadrant 2. 700 degrees is more than one full circle. So I want to figure out how much more, because the how much more part is where the terminal side will fall. So 700 minus 360 is going to be 340 degrees. So 340 degrees is coterminal, meaning if I can figure out where 340 degrees falls, that's got the same terminal side as 700 degrees. So 340 is in quadrant 4. So is 700 degrees. 15 pi over 8. If it helps you, change these to mixed numbers. 15/8 is 1 and 7/8 pi. So I like looking at it like that because I know that the bottom of the circle is 1.5 pi. Full circle is 2 pi. So we're just short of 2 pi, which means we're in quadrant 4. 3 radians. So this is not the same as 3 pi. Remember, pi is not a symbol for radians. It's a calculation. So this is not 3 pi. 3 pi would be same place as 180 degrees or pi radians. 3 radians is between 1.57 radians and 3.14 radians, so that's quadrant 2. Negative 210 degrees. So remember, with negative angles, you're just rotating down and around. So negative 210 should be down and around into quadrant. It goes through 3 quadrants, but that takes you up to quadrant 2. Another way to think of it is figure out where 210 would be, and then flip that across the x-axis. Either way, you're in quadrant 2. Negative radian angles. So again, it might help to write this down. Negative pi over 2 would be down at the bottom of the circle instead of being at the top. Negative pi is still a half circle. Negative 3 pi over 2 is at the top of the circle, and negative 2 pi is a full rotation this way. So negative 2/5 pi. So 2/5 is just short of 1/2, right? 2/5 is 0.4. So if you're only going negative 2/5, you're going to be in quadrant 4. Negative 4.5 pi. So we have to think about negative 4.5 pi. Let's start with negative 4 pi. Here's negative 2 pi, full circle. Another full circle gets you to negative 4 pi. You need to go an extra half in the negative direction. There's negative 0.5 pi. So, sorry, this didn't have a pi on your problem. Sorry about that. I forgot. I wanted this to land in a quadrant. That was about to not land in a quadrant. Negative 4.5 radians without the pi. So negative 4.5 would be, here's negative 3.14. Top of the circle is negative 4.71. So negative 4.5 falls somewhere in quadrant 2. And then negative 8 pi over 5. So again, change it to a mixed number. Negative 1, that'd be negative 1 3/5. 3/5 is more than 1/2, right? Because half of 5 is 2.5. So we're just past 1.5. So remember, the top of the circle is negative 1.5 pi. You have to go a little bit further than that, a little bit more. So that puts you in quadrant 1. Find one positive and one negative coterminal angle. So one positive, one negative. In degrees, we're basically going to be adding and subtracting 360. We may have to do that more than once if theta is more than a full circle. Do not convert to degrees. So if we're given a radian angle, instead of plus and minus 360, a full circle is 2 pi. So we're going to add and subtract 2 pi. So our first one is in degrees. So to get a positive coterminal angle, I can just add 360. So that would be 710 degrees. That's coterminal to 350. And if I want to get a negative coterminal, I start at 350 and subtract 360. And that gets me to negative 10 degrees. If you were to sketch all three angles, they would all have the same initial and terminal sides. It's just they have different rotations. Okay, theta is 3 pi over 7, so I'm not going to convert that to degrees. It wouldn't be easy to do that anyway. So I'm going to always start with the angle you're given, add 2 pi, and subtract 2 pi. So let's get a common denominator. So 2 pi is 14 pi over 7. So 17 pi over 7 is coterminal to 3 pi over 7. And then if we subtract, we get negative 11 pi over 7. And as long as you get a positive and a negative when you're adding or subtracting, you're finished. You don't have to keep adding or subtracting any further. So this is negative 4 pi over 3. We're going to add and subtract 2 pi. But when I show the work for that, instead of saying plus 2 pi, I want to make it over a denominator of 3. So plus 6 pi over 3. So that's 2 pi over 3. And minus 6 pi over 3. And if you're doing the work on your paper and you're just writing plus or minus 6 pi over 3, that's fine if you get the two answers. I don't have a set amount of required work to show. I just want to make sure that you're getting the right answers. Negative 500. So this is more than 360 degrees. Now, I could subtract 360, and I could say a negative coterminal angle is negative 860 degrees. That's acceptable. But then if I turn around and try to add to get to my positive, I'm not yet at a positive coterminal. If I do negative 500 plus 360, I get negative 140 degrees. So that's a negative coterminal angle. It's not positive. So far I still have two negatives. So if you want to get to a positive coterminal, you can think of this two ways. You could say, well, I needed to do negative 500 plus 720 to get this past two full circles would get me into the positives. Or you can break it up in steps. I just did plus 360. So take that answer and add another 360. And then that gets you to your positive 220 degrees. So I don't think it really matters. I find that the math, because I don't have a calculator on this part, is easier to do it in two steps like that. But here's a positive, here's a negative, and I could also have used the negative 860 for my negative answer as well. There are infinitely many answers. You can add or subtract any number of full circles to those answers. All right, convert each angle into the other measure. So if I have degrees, I want radians, vice versa. So make sure you have this memorized. If you want to go into degrees, or from degrees into radians, you multiply by pi over 180. And then you need to divide this. So we're just trying to reduce the fraction. You can divide it in stages, like by 5 first or by 3 first, whatever is easier. 15 goes into 18 once. 15 goes into 30 twice. So 15 over 18 does reduce to pi over 12. So whether you do that in one step or if it takes a few steps, it doesn't matter as long as you get to this final answer. 320 degrees times pi over 180. So if they both have zeros, I like to divide by 10 first. So now I'm just doing 32 over 18. So if I divide 32 by 2, I get 16 pi. 18 divided by 2 is 9. And those do not reduce any further. They don't have any common factors. Now we're going from radians to degrees. So we multiply by 180 over pi. So the pi's are going to cancel. You don't want to do 11 times 180. It's better to reduce first. 180 divided by 9. So 9 divided by 9 is 1. 180 divided by 9 is 20. So now I just have to do 11 times 20. So 11 times 10 is 200. 11 times 1, or 1 times, let me say that again. 10 times 20 is 200. 1 times 20 is 20. 200 plus 20 is 220 degrees. Gosh, maybe you did that faster than me. And then our last one here, 5 pi over 2 times 180 over pi. Pi's cancel. 180 divided by 2 is 90. 5 times 90 is 450 degrees. Make sure you write the degree symbol. It's easy to forget, but for your final answers, those are considered labels. If you don't write degrees, by default, you're talking about radians. Find the complement and supplement of each angle if one exists. So if the angle is greater than 90 degrees or greater than pi over 2, then there's no complement. If the angle is greater than 180 or greater than pi, then there's no supplement. It's possible to not have a complement, but yes, have a supplement. All right, so if theta is 25 degrees, we'd say the complement is 90 minus 25. That's going to give me 65 degrees, so that's the complement. The supplement is 180 minus 25. So 180 minus 20 is 60, minus 5 is 155. Same rule applies. If you're in radians, stay in radians, because pi over 13 is not easy to convert to degrees. It doesn't work nicely, and you're not going to have a calculator. Instead of 90 minus 25, what is 90 degrees in radians? It's pi over 2. So I still do the same math. It's pi over 2 minus the given theta. And then to solve that, you need common denominators. So they're both going to be over 26. So pi over 2 becomes 13 pi over 26. Pi over 13 becomes 2 pi over 26. So we get 11 pi over 26 as the complement. Supplements are much easier. It's instead of 180 minus your angle, it's pi minus your angle. And you're just subtracting from 1, so you can make this, show this common denominator if you want, or hopefully you can also do it in your head. But if you want to be safe, show the common denominator, and that's the supplement. If you're doing the math and you get a negative answer, that means there was no complement or there was no supplement. It means your angle was bigger than pi over 2 or bigger than pi. Complement for this one, 2 pi over 5. So pi over 2 minus 2 pi over 5. Let's get a common denominator of 10. So pi over 2 becomes 5 pi over 10. 2 pi over 5 becomes 4 pi over 10. And 5 minus 4 is 1 pi over 10. So there's the complement. Supplement is pi minus 2 pi over 5. So 5 pi over 5 minus 2 pi over 5 is 3 pi over 5. So supplement. Final problem. Now 5 pi over 7 is greater than pi over 2. If you recognize that right off the bat, the answer is no complement, no solution. If you're not really thinking about it, then you'd be doing pi over 2 minus 5 pi over 7. You'd set up a common denominator of 14. And you get a negative complementary angle. Complementary and supplementary angles are only positive, so there is no complement. There can be a supplement. Pi is bigger than 5 pi over 7. So when we subtract these, we do get 2 pi over 7, which is a positive answer. So this is just an obtuse angle. It's bigger than pi over 2, but it's not bigger than pi. Okay, something to memorize is the formula formula for radians. Excuse me. Because this is the formula to find theta in radians, theta has to be in radians for you to be able to use it. So if I give you any theta that has to do with degrees, you've got to convert it first. So let's just make that note. Theta is the angle in radians. S is the arc length. Like the angle opens up to some sort of arc on a circle, that's the arc length. And R, of course, is the radius of whatever circle we're talking about. Other things to note, if the question asks about linear speed, that's just putting arc length over a period of time. So if I say your arc length is 10 inches and you travel 10 inches in 2 minutes, that's 5 inches per minute. Angular speed is just the number of radians put to time as well. Okay, we would have a calculator for this section. So a car's wheels have a diameter of 28 inches. Start listing out. Your goal is to figure out what's theta, what's s, what's r, and which one of those variables is unknown. So r is 14 inches. Always include the label, just in case the radius and arc length, if they don't match up, then you've got to get them to match, be in the same unit. So r is 14 inches. How far will the car travel? That's asking for s. If the wheels revolve 10,000 times. Revolutions or rotations are related to theta. Now remember, theta has to be, this is a number of revolutions. Theta has to be in radians. Every revolution, every full circle is 2 pi radians. So 20,000 pi is the number of radians that we have for theta. Give the distance traveled first in inches and then in miles. So I have that just to kind of guide you. So first in inches just means solve for s. So we have theta equals s over r. Theta is 20,000 pi. S we don't know. R is 14. Even though I write radians, radians is not like a unit of measure. It's just, we're just giving this number here. So when you multiply 14 inches times 20,000 pi, the label is inches. It's not like inches times radians or anything like that. All right, so if I multiply 14 times 20,000 pi, a little bigger, there we go. I get this number. I'll write this down. So I'm getting that S is approximately equal to 879,645.943. This would be inches. Now the question said, give the distance traveled in inches, and then in miles. If you divide this answer, if you divide this answer by 12, that's going to convert your inches into feet, right? So divide by 12. And whether or not you write this down is up to you. So that's 73,303. Don't round this. You don't even have to write this down. I'm just doing it. So this is the number of feet. Divide that answer by 5,280. You do need to know how many feet are in 1 mile. So divide that answer by 5,280. And so to 3 places, now I can round 13.883 miles. So the question said, give the distance traveled in inches and in miles. So there it is. Notice that I left those decimals on my screen. I don't want you to use, like, you wouldn't round this shorter and then divide by 12, and you wouldn't round that and then divide. So just keep it all as accurate as possible. How many radians, find theta, will a car wheel of diameter 30 inches, r is 15 inches, make as the car travels a distance of 1 mile? The distance traveled is always the arc length. Because when we say a car is traveling, we're thinking, like, imagine that there's paint on the car wheel. And so as the car drives, it tracks this like straight line path. So that's the linear distance that we're talking about, even though it was an arc length wrapped around a wheel at one point. S is 1 mile. These do not match up. It's going to be a weird small decimal to convert inches to miles. So let's go ahead and say 1 mile is 5,280 feet. And let's convert that to inches. So 5,280 times 12 is 63,360. So we want arc length to be in the same unit as radius. Follow-up question, how many revolutions will the car wheel make? So let's start with theta equals S over R. S is 63,360 inches, and R is 15 inches. So when those cancel, there's no label left. Theta is by default. Remember, this is a definition of a radian, so this is how many radians theta is. So it was that number divided by 15. 4,224. There's no label for radians, but I like writing the word radians just so I know what I have. So here's theta in radians. How many revolutions is that? Well, how many radians are in a full circle? 2 pi. So if we take this number and we divide by 2 pi, being careful to put that in parentheses, that should tell us how many full circles that is, right? Like 720 divided by 360 is two full circles. Same idea, but with radians. If you don't put parentheses around 2 pi, you will not get the same answer. So be careful. Because then the calculator will divide your answer by 2 and it would multiply it by pi, but we want it to divide. So this is about 672.270. And my answer on that would just be revolutions. Excuse me. The next question, I thought this was pretty interesting. So I'm actually going to link a little like 6.5 minute video back from 1980. It's pretty funny to watch. But anyway, with like more on this, because this is an accurate story and it's just pretty cool. So pretty amazing the math that they did back before they had anything close to the technology that we have today. Okay, Greek mathematician Eratosthenes lived between 276 and 195 BC. He measured the circumference of the Earth. Well, he approximated the circumference of the Earth using the following information. So he noticed that on a certain day, I think this might have been when the sun was was it closest to the Earth? I can't remember now. It's in the video. He noticed that on a certain day, the sun shone directly down a deep well in Syene. At the same time in Alexandria, 500 miles north, on the same meridian here, the rays of sunshine shone at an angle of 7.2 degrees. And so if the Earth was flat, then it wouldn't be possible. If the Earth is flat, they should be shining at the exact same angle. Use this information in the figure below to find the radius and circumference of the Earth. So, okay, in the figure below, there's a bit of geometry that we're working on. Here's what we know so far. S is 500 miles. That's definitely an arc length. That's clearly marked. How does this 7.2 degree angle help me? Well, this side here is parallel to the radius of the Earth right here. And so if this is 7.2, this is 7.2. I think those are called like corresponding angles, possibly. I'm a little rusty on my geometry. But the angle that's given out here does equate to this central angle. So we do know that theta is 7.2 degrees. But remember, you've got to convert that to radians by saying times pi over 180. Now, I don't want to round this, so I'm just going to leave it like this. And the question is, find the radius of the Earth. So theta is equal to S over R. If we put in what we know, we've got 7.2 pi over 180 equals 500 over r. Let's multiply r to the left side. You can say 500 divided by this fraction, or you could say times the reciprocal of the fraction. It doesn't really matter. So when I type this in, let's see. This is the actual radius of the Earth, so it's going to be, we should have something pretty close, which is just, again, I think that's just amazing. How they figured all this stuff out. So this says that the radius of the Earth would be approximately 3,978.874 miles because the original distance was miles as well. My one question was, I took this from a textbook. The miles thing was like, wait, did they measure using miles? And I believe they were in Egypt somewhere. I'm not sure on that, but it doesn't really matter. Whatever distance they have, this would still come out whatever distance they measured this in would still come out to that many units. So it would be accurate, pretty accurate. We're only off by like about 20 miles. That's pretty crazy. Okay. Next problem. To measure the speed of a current, scientists place a paddle wheel in the stream and observe the rate at which it rotates. If the paddle wheel has a radius of 0.2 meters, so no adjustment to make there, and rotates at 100 RPM, that means revolutions per minute. So theta is 100 revolutions per minute. That's actually an angular speed, right? That's like theta put to time. So we could say, well, whatever, 100 revolutions per minute. Let's start with theta. So theta is 200 pi radians. And let's put in an extra component of time. Time is 1 minute because that rotation was happening per minute. Find the linear speed of the current in meters per second. So let's change minutes to seconds. That's 60 seconds. All right, so that's done. And linear speed, I have this at the top of the page, but don't let this scare you. Linear speed is just distance traveled, which is arc length, divided by the time period that we're talking about. All right, now arc length, we've rearranged this a couple of times. If theta equals S over R, then S equals R times theta. All right, so R was 0.2, theta was 200 pi. We're dividing this by 60 seconds, only because it says meters per second instead of meters per minute. So the linear speed, which I'm just going to call LS, is 0.2 times 200 pi divided by 60 seconds, 2.094. And the label on that is meters because that's what R was measured in, per second because that's what the time that we divided by. All right, what else do you have to know how to do? This is non-calc again. Draw both special right triangles, so make sure that you have memorized how to draw the special right triangles. And just with the shortest leg being 1, you don't have to do the X thing that we did in geometry. So draw them in any way, oriented any way that you want. The scale is not as important as just having the right numbers. So 30, 60 is what I do. Also, know to label in the radians, the correct radians, because you can see the questions are mostly asked in their radian form. The side opposite 30 or pi over 6 is 1. The side opposite 60 is radical 3. And the hypotenuse is 2. I might not get through this whole section before the bell rings, so the next video will pick up where this one left off, just FYI. The other special right triangle you need to know is 45, 45, 90. The radians for 45 degrees is pi over 4. And the side lengths are 1, 1, radical 2. The amount of work you show for these is up to you. Cosine is adjacent over hypotenuse. So find pi over 3. Adjacent to pi over 3 is 1. Hypotenuse is 2. Tangent is opposite over adjacent. Find pi over 6. Opposite is 1. Adjacent is radical 3. Always rationalize these answers. So radical 3 over 3 is my final. Find pi over 4. Sine is opposite over hypotenuse. Opposite is 1. Hypotenuse is radical 2. Radical 2 over 2. It doesn't matter which angle you pick, by the way, because they're the same. Secant of pi over 4. Secant's the reciprocal of cosine. So it's hypotenuse over adjacent. The hypotenuse in the pi over 4 triangle is radical 2. The adjacent side is 1. Simplify that to radical 2. Cotangent of 45. So tangent's TOA. So this is adjacent over opposite. 1 over 1 is still just 1. Cosecant of pi over 3. Cosecant is the reciprocal of sine, so it's hypotenuse over opposite. Find pi over 3. The hypotenuse in that triangle is 2. The opposite of pi over 3 is radical 3. Excuse me, and then you rationalize. Tangent of 60 degrees. So find 60 degrees. Tangent is opposite over adjacent. So radical 3 over 1, which you have to simplify as radical 3. You don't want to get counted off or not full credit on the AP exam just for being lazy and not simplifying things. So please get in that habit. And finally, cosine is adjacent over hypotenuse. So adjacent to 30 degrees is radical 3, and the hypotenuse is 2. All right, I'm going to stop this video at this section, and then we'll carry on the rest in the second video.